Hello everyone, welcome to our webinar today. This is Shabaz. I'm a product manager in the Azure Network Security Customer Experience Engineering team here at Microsoft. Today we will be talking about Azure DDoS Protection Service and how we can make the most of it by utilizing first-party integrations. Here's the agenda for today's session. We will start with looking at what are the different attack trends and types, and then we'll talk about different DDoS protection offerings in Azure. We will cover different integrations we have for Azure DDoS protection. And finally, we'll spend some time on the demo. So let's get started. A quick recap about DDoS attacks. So DDoS attacks, in other words, distributed denial of service attacks, are a type of attacks which attempt to exhaust the application's resources by sending large amounts of traffic, thereby making the application unavailable to the legitimate users. So why we should be caring about these attacks is that basically any public IP that is exposed to the internet is susceptible to DDoS attacks. So if you have any application that is internet facing, you need to make sure that you are protected from these type of attacks so that your application's availability is not affected. Let's take a look at the recent DDoS attack trends. Beginning in mid-March 2024, we observed a rise in network DDoS attacks, reaching approximately 4,500 attacks per day by June. Additionally, there was a significant surge in attacks targeting medium-sized applications. Unlike traditional network attacks, application layer attacks are more stealthy and complex, making them harder to mitigate. These attacks, which are in range of 100K to 1 million packets per second, are aimed directly at the specific web applications, revealing the relentless nature of attackers trying to evade volumetric DDoS protection tactics. Without proper protection, these applications could face serious disruptions, affecting critical services like online banking and airline check-ins, etc. As attackers shift their focus to application layer vulnerabilities, businesses need stronger security measures to maintain service availability and protect their users. Let's go over the different type of DDoS attacks. The first one we have here is the volumetric attacks. These attacks flood the network layer with a substantial amount of seemingly legitimate traffic. Because of this, excessive network bandwidth gets consumed, thereby saturating the network layer, making it non-functional. These attacks are easy to generate either using DDoS for hire services or with attackers employing simple amplification techniques. These attacks are measured in bits or packets per second, and some of the examples of these attacks are ICMP flood, IPsec flood, and UDP flood. The next type of attacks we have are the protocol attacks or state exhaustion attacks. This type of attack causes a service disruption by consuming all of the available capacity of the web application servers or the capacity of intermediate resources like firewalls and load balancers. It abuses flaws on the network layer, exploiting protocols like IP, ICMP, and IPsec, and on the transport layer, exploiting TCP and UDP protocols. The most common example is the TCP SYN flood attack. This attack exploits the TCP handshake by sending a large amount of TCP SYN packets with spoofed source IP addresses. The victim machine then responds to each connection request and keeps waiting for the response to finalize the handshake. But these responses never come back. As a result of this, all of these requests stay in an open state, causing the system to exhaust all of its resources and become unresponsive. The next type of attacks we have is the resource attacks or application layer attacks. These are layer 7 attacks that target the backend server. The goal of these attacks is to exhaust the resources of the target application and to abuse flaws and vulnerabilities on the application itself. For example, targeting how web pages and web servers handle HTTP requests. Generally, HTTP request is simple to execute on the client side, but it depends, it demands a lot of resource from the target server to respond because the server likely loads any files, runs database queries, etc. So this type of attack is a challenge to identify and defend against because the traffic seems very legitimate. DDoS protection by itself does not protect against layer 7 protocol attacks here. We must use a web application firewall such as Azure WAF in conjunction with DDoS network protection to provide defense against these type of attacks. Some of the examples of these attacks are HTTP flooding, slow loaders, etc. We also have rate limiting and bot protection rules in both App Gateway and AFD WAF, which can help with flooding attacks. Now let's talk about Azure DDoS Protection. Azure DDoS Protection comes in two SKUs. The first one here is the Azure DDoS Network Protection. It provides enhanced DDoS mitigation features to defend against DDoS attacks. It's automatically tuned to help protect your specific Azure resources in a virtual network. It currently covers 100 public IP resources at a cost of 3,000 USD. A single DDoS protection plan can be used across multiple subscriptions under a tenant. So there's no need to create more than one DDoS protection plan. It comes with features like adaptive tuning, attack analytics and metrics, Sentinel and MDC integration, DDoS rapid response, SLA guarantee, and cost protection. Adaptive tuning will help with setting up protection policies that are tuned to your application's traffic profiles. It utilizes machine learning algorithms to set mitigation thresholds. It can perform dynamic profiling of the normal traffic patterns of the IP every minute, thereby predicting the expected traffic for the IP over the next 15-minute interval. Then the attack analytics will help with detailed reports in 5-minute increments during an attack and a complete summary after the attack ends. We can stream these mitigation flow logs to Microsoft Sentinel or an offline security information and event management system for near real-time monitoring and during an attack. The next one we have here is the DDoS rapid response. During an active attack, Azure DDoS Protection customers have access to the DDoS rapid response team, who can help with attack investigation during the attack and also with post-attack analysis. This team will help with custom mitigation policy configurations. And finally, the SLA guarantee gives us the 99.99% SLA guarantee that during attack, the target resource will not be impacted. And the cost protection will help us with service credits for resource costs incurred as a result of a documented DDoS attack. So these are the important features of Azure DDoS Network Protection Plan. Most of these features are also available in the next SKU, which is the DDoS IP protection SKU, but there are some differences. We'll talk about them. So the next SKU is the DDoS IP protection SKU. It is a SKU that can be directly enabled on the public IP. This SKU is designed for small and medium businesses as it is cost effective and providing enterprise grade DDoS protection. It has the flexibility to enable protection on an individual public IP for around 200 USD per month per IP. So it is easy to configure and monitor and comes with MDC and Sentinel integration similar to that of network protection. Let's go over the comparison between these two SKUs. So as we can see here, all of the important features are available in both the SKUs, but there's only one difference, that is the DDoS rapid response support and cost protection. They are not available in the DDoS IP protection SKU, whereas those two features are available in DDoS network protection SKU. A bit about the pricing of these SKUs. The DDoS network protection pricing, it comes with 3K USD per month for the entire tenant, and it's a fixed cost. This will cover 100 public IPs. And if there are more public IPs that we want to protect, there will be an extra charge of $30 per month for each public IP above 100. This includes everything like rapid response support, cost protection and everything. Whereas the IP protection pricing goes like this, like we have to spend 199 USD per month per public IP. This is also a fixed cost. So it depends on what our requirement is, and we have to select the SKU accordingly. Now let's talk about Azure DDoS Protection first-party integrations. Firstly, we need to make sure that the diagnostic settings for a given public IP address are properly configured to utilize all the integrations that are currently available. Here we need to make sure that the three important log categories like the DDoS protection notifications, DDoS mitigation flow logs, and DDoS mitigation reports, along with the metrics, are enabled and being sent to the specified log analytic workspace, as we can see here. The first integration we have is the Azure DDoS Protection Workbook that is available in Sentinel. This can also be downloaded from our GitHub repository. This workbook can be used to get insights into various DDoS attack patterns in our environment in a single dashboard. You can get insights about the attacks like what were the source IP addresses, what were the countries, top attack vectors, etc. So this information will help the security analysts to understand the current traffic patterns in the environment and also for troubleshooting purposes. The second integration we have is the Microsoft Defender for Cloud integration. So within Microsoft Defender for Cloud, we get recommendations for unprotected public IPs and VNets. We also can be able to get alerts about DDoS attacks within our environments. So we'll take a look at these alerts and recommendations when we are doing the demo. But this is also very helpful when we are actually monitoring the DDoS attacks in our environment. And then the important integration we have here is the DDoS solution for Microsoft Sentinel. So using this solution, we can set up automated detection and response to attacks using Azure Firewall and Azure WAF. This solution sets up a data connector to bring Azure DDoS Protection diagnostic logs into Microsoft Sentinel and also sets up two analytic rules. The first one is the percent threshold rule, which identifies IPs generating more than 5% of attack traffic, while the other one is the packets per second threshold rule that identifies IP addresses exceeding 10K packets per second. By utilizing the information caught by these analytic rules, users can set up automated responses like blocking the attacker IPs on a WAF or a firewall. Businesses can install this solution through Azure Marketplace or directly within Microsoft Sentinel to strengthen their defenses against evolving threats. For example, in this slide, the DDoS Sentinel solution integration with Azure WAF playbook has been demonstrated. The diagram describes how the solution works and what steps are taken from the attack detection to remediation. So first of all, the malicious actor launches the DDoS attack, and the Azure DDoS Protection mitigates the attack and generates logs that are transmitted to Microsoft Sentinel. Then Microsoft Sentinel extracts the source IP addresses of the attackers from those logs and triggers the WAF playbook. The attack IP addresses added to a custom WAF rule with a block action, and this will be done with the help of that WAF playbook automatically. Now, having employed the DDoS attack as a smokescreen, the attacker now attempts to breach the application to take the sensitive data. But then at this point, the Azure WAF acts by blocking access from the source IP address of the attacker since we've configured the custom rule. So this is the flow of this integration. This is an example with WAF playbook. We also have a firewall playbook in a similar workflow. We can also take a look at that. But in this demo, I'll be demonstrating this particular scenario here. Now let's spend some time on the demo. So this is the public IP address that I'm concerned about. First thing is we need to check whether this public IP address is protected with the DDoS protection or not. So when we click on this protect button here, we'll be able to see that this public IP is currently protected. And this is related to the DDoS protection plan, DDoS telemetry test, right? And then if we look at the metrics section here on this public IP, there are a few important metrics which we can make use of for looking at the environment and see if there are any DDoS attack in different details. So for example, if we select a particular metric, there is a metric called under DDoS attack or not. So if we select this, and if I put the date as last 7 days here, as we can see, generally it's 0 if we don't have a DDoS attack, but on May 30th, we had a DDoS attack. So it turned to 1 at that point. So this is an indicator and it will also generate alerts for us that the DDoS attack has started. Right? There are other metrics which we can make use of. So during this time, so let me add a new metric here. So let's see. There's a metric called inbound TCP SYN packets to trigger DDoS mitigation. So this is the auto-tuned threshold that is configured by the DDoS protection. So let's take a look at this. So this is configured as 20K packets per second at this point. So this threshold is automatically configured, right? Now I want to take a look at how many SYN packets that came in during that attack time. So let's take a look at the inbound SYN packets. So inbound packets DDoS. So we had around 50K packets during this time, this attack time. But if we want to take a look at how many packets of those were actually forwarded to the application. So if we click on this inbound packets forwarded to DDoS, so we can see that there were only 51 packets per second that were forwarded. So most of the malicious packets were dropped and the DDoS attack was mitigated. So this is really important information here, and there are other metrics that we can make use of as well. Those will be really helpful. Now, the second thing I wanted to talk about here is the diagnostic settings. So these diagnostic settings are really important for any public IP address, right? So this is the place where we configure how the logs are of the DDoS attack or anything for this public IP or where these are being sent to. For example, we have this setting configured here. So where we are sending all of these DDoS protection notifications, flow logs, and reports to our demo workspace. So this is where all of these logs will go to, and we can take a look at those logs, and also those will be able to help us out with troubleshooting. So now let's go to the workspace that we configured there. So these are some of the queries that I already have here. So these are the queries related to different types of logs that we have available for the public IP. So first one we have is the DDoS protection notifications. So if I run that particular query, we can see that there are 2 log entries, and this happened on the same date when the DDoS attack happened. So this was on May 30th. So we can see that what type of attack was this, what are the details and which resource was affected, and mainly what type of notification was this. This was the mitigation started notification. And then similarly, there should be a mitigation stop notification also. So this is the mitigation stop notification once the DDoS attack got mitigated. So with the help of this log type, we can get these type of notifications. And then there are the second log types, which are the DDoS mitigation reports. So if I run this particular query, this query will give me all the incremental reports on how the DDoS attack was happening, what are the packet numbers, protocols, drop reasons, all of those details are available here, right? So as we can see, this report type is incremental, and and if we look at the logs here, we have a incremental report after every 5 minutes, as we can see here. So all of these are incremental reports, like I said, but the last one should be post mitigation report. So the last one will give us the comprehensive report on how what this DDoS attack was about, and what are the different drop reasons, what are the top source countries, source ASNs, and what are the protocol that were attacked, and everything. All of those details are available in these logs. And on top of this, there's this third type of log category. So this log category is also very useful. So if I run this particular one, this log category will give us information on each of the packet that was either dropped or forwarded during that DDoS attack. So this is also very helpful if we want to look at every single detail during that DDoS attack and look at all the packets and what type of packets were coming in. And that's where the troubleshooting gets even to the point. So this is where, as we can see, the message is saying that the packet was forwarded to the service. So likewise, we can see the details of different source protocols and all of the information in these type of logs for each and every packet. So as we've seen here, we are seeing all of these logs within the workspace, and it takes a bit of time to research all of this and correlate everything here. But to make it easier, that's where the workbook for this DDoS protection comes in handy. So let me show you the workbook here. So this is the workbook. I've already installed the workbook within the resource group that I'm presenting here. But generally, you can get this workbook, like I mentioned, through the Sentinel solution for DDoS protection, or you can get it directly from our GitHub repository. Now, let's select the workspace here. So I'm going to select the workspace that I'm demonstrating for this purpose. And this is selected for last 90 days. And as we can see here, as soon as we have the workspace populated there, we can see the total number of packets that came in, total number of packets dropped, TCP packets, UDP packets, and other packet types, last 10 DDoS attack reports, and which were the resources that were affected, protocols, continent of origin, countries of origin, AS numbers, drop reasons, everything in a single dashboard. So this will give us a comprehensive understanding in a single of all the DDoS attack that happened within our environment in a single dashboard. So this is really, really helpful in saving our time, and also very helpful in troubleshooting and going back in time and looking at all the DDoS attacks in our environment. So moving on, after the workbook, just wanted to highlight that we had a blog that was published, which was Azure DDoS Protection SecOps Deep Dive. So this is a great blog that talks about how you can troubleshoot every nitty-gritty detail of a DDoS attack utilizing our Azure DDoS Protection services, and also the metrics. There are various queries and everything are available here in this blog. So I highly recommend to check it out. This is available in our Microsoft Tech Community Azure Network Security blog space. So check it out when you have a moment. Then moving on, the second integration that I was talking about is the Microsoft Defender for Cloud. So this is the MDC dashboard here. And if I go to the recommendations section and search for DDoS. So we have a few recommendations here. For example, there are quite a few recommendations for some of the VNets, and the recommendation is about Azure DDoS protection should be enabled, right? So this type of recommendations we get if any of our public IPs or any of the VNets are not protected by a DDoS protection plan. So that's really helpful. And the other thing we have in the MDC dashboard is that within the security alert section, if we search for DDoS again here, we can see the list of alerts that happened. This is a high severity alert. There was an attack in like on June 1st, there was an attack. The May 30th, there was an attack, various attack events, and all of those are logged here. So we'll also get a notification whenever there is an alert that came in. So MDC also help us out in actively monitoring these type of attacks. So this is also an important integration. And then the next one we have is the actual Sentinel solution for DDoS protection. But before talking about that, I just wanted to set some context here. So this is a WAF policy that I'm currently using for protecting my web applications, right? So here in this policy, there are custom rules that I've configured. There is a custom rule called Sentinel block IP. This was automatically configured by one of our playbooks that I'm going to demonstrate. But as we can see here, currently this Sentinel block IP has 4 IP addresses from a previous DDoS attack, right? So what I want to demonstrate here is when we use the Microsoft Sentinel solution for DDoS protection, we should be able to automatically add malicious IPs to this block list here in this rule. And that we are able to be, we'll be able to do that with the help of the block IP WAF playbook that we currently have. So let's take a look at how all of this works together. So I'm closing this one out. And let me go to the next tab here. The next tab is our Microsoft Sentinel. So here within Microsoft Sentinel, if you go to the Content Hub section and search for DDoS. So as we can see, this Azure DDoS Protection solution is already installed, so we don't need to install it. If at all you haven't installed it, you can go ahead and install it directly. But if I click on generally you'll get an install button here, but since I have it installed, I'm getting a manage button. And if I click on that manage button, I'll be able to see what's available as part of that solution. So as we discussed, this solution is giving us a data connector, 2 analytic rules that we talked about, and a workbook, right? So just wanted to show how you can install the solution. Once you have installed the solution, there are 2 important places where you can take a look at some of the analytic rules and also the automation rules. So number 1, if you come to the analytics section here, so there is this rule that we are going to make use of right now. So if I click on edit to this rule, there is a query that this analytic rule will run. And if I click on set rule logic, this is the query that it's going to run. And it's going to run for run every 8 days and look up data from the last 8 days. We've kept this way because it will be easier for us to demonstrate here, but you can choose the frequency and when you want to look at the data from, you can choose that as per the requirement. So closing this one out, this is the analytic rule that is already in place. And there's also an automation rule that we have set up. So this is the DDoS WAF solution automation rule that we have set up for this. And what this automation rule is going to do is whenever there is an alert created by that analytical rule, what happens is this automation rule will trigger this block IP Azure WAF playbook. So this playbook is currently available in our GitHub repository. You can download and install it from our GitHub repository under the WAF section, WAF playbook section. So this is the place where it is available. You can directly deploy to Azure, and you can deploy it to your resource group that you're working with. Now, once this automation rule gets triggered, the playbook will start running, and what that playbook does is it will identify all the malicious source IP addresses, and it will add those malicious IP addresses to the block list that I just showcased before, right? So let's see how it is going to work. So for demonstration purposes, I'm not going to run a DDoS attack right now because we've already done it, simulated a DDoS attack. But for easy demonstration, I'm going to disable and re-enable this particular analytic rule. So what that will make is it'll make that analytic rule check for the data again in the last 8 days. And if there was any DDoS attack, it will pick up that information. So let me do this. So I'm disabling this analytic rule. Now it's disabled. Want to re-enable this. Like to give it a minute. And enabling the analytic rules again, right? So this will run again now. And if there was a DDoS attack, it will get picked up, right? I think I closed it out, but yeah. So if I come back to this incident section, there you go. We have an alert created. There was a previous one that I was trying, and this is the one that we just got. So this is the alert related to the enablement of the analytic rule that we just did. So if I look at the full details of these alert, we'll get information on what this alert was about, and let's see what all it has. Okay, so this alert was created as a result of this percentage threshold analytic rule. So we should also get the IP information here, but I'll show it to you. So in the incident actions, we can run a playbook as part of this alert, or we can set an automation rule. Since we have already set up an automation rule, we don't need to run it manually, so it'll have done its job already. So what I'm going to do right now is I want to check if that playbook has run and if my WAFs policy has been updated. So let me go back to the playbook here. So this is a playbook, the block IP Azure WAF, and this playbook was already installed in my resource group. And this is the logic behind it. You can take a look at this and you can read about this playbook. This will work with both the AFD WAF and also the App Gateway WAF. Now I just want to check it run history. So it just ran right now at local time 2 minutes before now. So I think this has already updated the IP addresses on that block rule that I showed. So let me double check that. So now let's go to the policy. So this is the policy, and let me refresh this. And if I click on this Sentinel block IP, as we can see, previously there were only 4 IP addresses, but these are the new IP addresses that were added by the playbook now. So now we have totally 8 IP addresses that are added to the Sentinel block IP rule. So what happens is if you don't have a custom rule at all, it will create a new custom rule with this name and add those IP addresses and then deny the traffic. So this is how the flow works. So similarly, just like this, you can also use playbooks that are available for firewall as well. So in this way, you can do automated blocking of any malicious IPs with the help of the Sentinel solution for DDoS protection and also the playbooks that are available. So I'm going to close this one out. And the last thing I would like to talk about is, so if you go to aka.ms/az-netsec, you can access our GitHub repository. Under GitHub repository, there is a section for each of these products like Azure DDoS Protection Firewall and WAF. Under WAF, this is where you find all the playbook for WAF and related artifacts. Like this is the one that we just talked about. And similarly, if you look at firewall, you can find the firewall related playbooks there, right? But the one that I wanted to show here right now is under Azure DDoS Protection. There is a section called Policy, Azure Policy Definitions. So within Azure, we have Azure Policy that is really helpful for governing our Azure deployments, as in we can make sure that certain conditions are actually implemented within our policies or within our configurations. For example, if we want to make sure that a particular public IP address is protected with DDoS protection plan, then if we implement a policy, Azure policy at that point, it'll help us out and it'll tell us whether this public IP address is compliant with our policy or not. So that way we'll be aware of which IP addresses are protected, which are not. So in that context, we have a few policies that are created by our team here, and it's readily available within our GitHub repository. So for example, there is a policy called public IPs should be protected with DDoS IP protection, and public IPs with a specified tag should have DDoS protection enabled. Also, any application gateway public IPs should have DDoS protection enabled. Some of these are really useful if at all you want to deploy them as a custom Azure policy. You can use the definition that is available within this. So this is a simple definition file that you can make use of and copy that definition and create a custom policy with the help of it. Any of these will be useful here, right? So those are some of the items I wanted to talk about when it comes to integration, right? There's also some information on Azure DDoS solution for Microsoft Sentinel. There is a blog that was published by one of our team members, Salim, which is like a really useful blog. It talks about so many details on how we can integrate the playbooks with firewall and how the Sentinel solution is really useful in blocking malicious IPs. So I highly recommend checking this one out as well. And also in our documentation, we have a section for automate your attack response with Azure DDoS protection solution for Microsoft Sentinel. So it covers all the playbooks and Sentinel solution details we have. So I recommend to check that one out as well. Right, so that's about it from my end for today. So would like to give some time back for any question or answers if we have.
Great, sounds good. Yes, if any other attendees have any more questions that they'd like to submit, please continue doing so. It looks like we have one good one that we can go over. It says, how does DDoS network protection plan get triggered if it is sitting behind the Azure front door, which has the Azure infrastructure DDoS protection? And and it continues on to say, to give you an example, using AFD as the ingress edge service for the environment will have Azure infrastructure DDoS protection automatically applied. If your next hop is an AP gateway and this VNet has your DDoS network protection plan applied, how does the paid plan get triggered?
Yeah, that's a great question. So generally, when we look at Azure front door setup, Azure front door automatically comes with infrastructure DDoS protection. So we don't have to configure the network DDoS protection at that point. So any traffic that is coming directly to the AFD, it will be any DDoS attacks, they'll be mitigated with the help of infrastructure DDoS protection. So in case there is a chance that some of your public IP addresses in the backend, they are exposed to the internet, and if they are like if the attacker knows about them, there is a chance that the attacker can directly access those public IP addresses and start an attack directly to them, right? So the recommendation is that if you have AFD enabled, you need to make sure that you have your rate limit thresholds and everything in place at that point for your layer 7 DDoS protection, and your layer 3, layer 4 DDoS protection is already taken care of with the help of infrastructure DDoS protection. But as a best practice, we always recommend to have the network protection also enabled for the backend resources for one of these rare situations where they are exposed and we want to protect them from any malicious activity.
Great, thank you. And our next question says, what happens if you are not using Sentinel? Is there playbooks you can still use?
So playbooks are generally nothing but they're logic apps, right? So and Sentinel is a SIEM solution where you're collecting all of the logs and basically mapping everything to the events that we have there, right? So it all combines as an automated solution. But if you want to run a logic app separately without any trigger point, you can do that. You can create your own playbook, and you can configure the logic that you want, and you can manually trigger it. But the recommendation is that the playbooks, the main purpose of them is if you want to put in some automation, and if you want to have that automation in place, and if you can utilize the Sentinel logs at that point, you can have a complete solution. So you can look at the triggers from Sentinel and incidents from Sentinel, and as a result of those, you can trigger the playbook, and then you can have any automation implemented. But per se, there is no direct requirement or mandate that you have to use Sentinel or you have to use playbooks. It's up to your requirement.
Great. That sounds good. And it looks like that was our last question. All of our other questions have been answered in the chat. So thank you so much, Shabaz, for being our guest today and for sharing this great information with our community. Also, thank you so much to the Q&A team who helped us with answering the questions and providing the resourceful information. To all the listeners still on the line, if you're someone who wishes to aid in the protection of the world from cyber threats and desire to have a say in shaping our strategies, blueprints, and recommendations, then we invite you to become part of our security community. Together, we can make a global impact. So join us at aka.ms/securitycommunity. This is also where you'll be notified about the upcoming webinars, events, and other announcements. For those of you who may have additional questions on the topic we just covered or other product-related questions, please feel free to raise them on our Microsoft Tech Community Discussion Space at aka.ms/anscommunity. Thank you all for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.